Again, good morning, grade 7. We are now done with the introductory activity, but only few of you actually did the introductory activity. Well, anyway, I already given you chances, and we need to move forward, right? So let's start with the lesson prepper. Let me share my screen. Let's start with waves, light, and sound, right? So, again, as what I had told you a while ago, that we are done with the introductory activity and only few actually did the activity. So anyway, again, let's move forward. Waves. Waves always begin with the source of energy that causes a back and forth or up and down disturbance or movement. Again, waves are disturbances. Please again turn on your camera. A wave is a disturbance that transfers energy from one place to another without transferring matter. Just like when you are actually moving a spring, okay? Or you're moving a rope. You're transferring energy, but you're not actually transferring the matter itself, okay? Energy transfer to waves. Waves. When you lift a pebble, you transfer energy to it. So, by the way, by lifting the pebble, how can you transfer energy? What are the energy being transferred there? Any idea, grade 7? Kung binisayon, kung alsahon ang pebble, what are the energy being transferred there? Any idea? What are the energy acting on it? What are the forces acting on it? Any idea? Grade 7? Any idea? Are you still with me? Okay. When you lift a pebble, remember that the pebble is in the ground, right? And you're lifting it. So you actually give some force to act on the gravitational pull, okay? From static energy to kinetic energy, okay? And then you transfer energy to it. Suppose you drop the pebble. Again, when you drop a pebble, the gravitational pull is acting again on it, okay? The pebble's energy transfer to the water. Waves carry energy away from the point where the pebble hits the water. Okay? Again, when you lift a pebble, you're actually transferring energy against gravity. That is against gravitational pull. Because the pebble there has gravitational pull. But when you lift it, you are actually against gravity. And the energy there is from potential to kinetic energy. And then when you drop, again, gravitational pull or gravity is acting on it, which is 9.8 meters per second squared. Okay? And energy transfer to the water, to the ripple effect. Okay? Waves carry energy away from the point where the pebble hits the water. That's the ripple effect. The water itself moves up and down as the wave passes, but water does not move along with the wave. There are two main types of waves. Some waves carry energy only through matter. Other types of waves can carry energy through matter or empty space. Okay, let's take a look at the types of waves. The first one is the mechanical wave. Okay, a wave that travels only through matter is a mechanical wave. A medium is the matter through which wave travels. A mechanical wave forms when the source of energy causes particles that make up the medium to vibrate. Like for example, a pebble falling into the water transfers its kinetic energy to the particles of water. Okay, mechanical wave needs a medium. Okay, it needs a medium in order for it to travel. That's the mechanical wave. Like for example, sound wave. It's a mechanical wave. What else? The ripple effect or the water from a pond. Yes, it's a mechanical wave. What else? What else? What do you think are the other mechanical waves? What else? The rope. When you play with the rope, you're actually transferring mechanical waves. What else? Those are mechanical waves. The second wave, this is the ripple effect. Okay, as you can see, that the wave is actually moving away from the source. The second wave is the electromagnetic wave. Okay, a wave that can travel through empty space or without medium or through matter is an electromagnetic wave. This type of wave forms when a charged particle such as electron vibrates. Like for example, electromagnetic waves transfer the sun's energy to Earth through empty space. Okay, what they call the sun's um, wave? It is called ultraviolet waves or UV. It actually travels in space or vacuum or without medium. Once waves reach Earth, they travel to matter. They can also travel to matter, such as atmosphere or a glass window of your house. Okay? Do you have any questions so far with the two types of waves? Questions so far with the two types of waves? Okay. So these are the electromagnetic waves, radio waves, microwaves, infrared, visible light, ultraviolet rays or UV, X-rays, and gamma. Let's tackle the different electromagnetic waves later. Describing wave motion. Some waves move particles of a medium up and down or side to side, perpendicular to the direction the wave travels. Transverse waves. Okay? A wave in which the disturbance is perpendicular to the direction of the wave travels is a transverse wave. Just like your electromagnetic waves, they are transverse waves. Okay? Electromagnetic waves are transverse waves. Yes, the electric and the magnetic disturbances are perpendicular to the motion of the vibrating charge. Just like this one, this is a transverse wave. As you can see, the parts of the wave are exposed there. Okay? The crests, the highest point, Okay, up the wave, the throw, which is the lowest point, the wavelength, this is the distance between crest to crest and throw to throw, and the amplitude, which is the distance from the central axis going to crest or going to a throw. Question so far? Longitudinal waves. A wave that makes the particles or medium move back and forth to the direction of the wave travels is a longitudinal wave. Okay? Longitudinal waves are mechanical waves. Like a transverse wave, a longitudinal wave disturbances passes energy from particle to particle of a medium. Just like this one. Okay? Sure. Where can you observe the longitudinal wave? You can observe longitudinal waves in springs. Okay. Diba? When you move back and forth the spring, the waves actually move by compression and rarefaction. Okay? Compression and rarefaction. So let's tackle later about compression and rarefaction. Okay. If this is transverse wave, up and down, the longitudinal waves are back and forth. Okay? We have compression and rarefaction there. Waves in nature. Okay. Where can we observe the waves in nature? Waves are common in nature because many different energy sources produce waves. Okay. Two different energy sources, two common waves in nature are water waves and seismic waves. Okay. Water waves. Although water waves look like that's transverse waves, water particles move in circles. Okay. Water waves are a combination of transverse and longitudinal waves. Water particles move forward and backward. They also move up and down. As a result, is a circular path that gets smaller as the wave approaches to the land, just like um, the illustration, this one. Okay, it moves up and down at the same time. It's moving back and forth. Okay, water waves form because there is friction between the wind at the sea, wind on the top part of the water, and the water itself. Energy from the wind transfers to the water as water moves toward the land. Like all waves, water waves only transport energy because the waves move only through matter. Water waves are mechanical waves. They are mechanical waves. Okay? But a mixture of longitudinal and what? Longitudinal and transverse wave. So you can see that the air is moving here and there is a movement up and down in here. So the result is a circular motion. Okay, so this is the illustration. If the air is going here, okay, the direction of air is here. So there is also movement up and down, making it circular motion or has a circular motion. Let's move now to seismic waves. When layers of rock of Earth's crust suddenly shift, an earthquake occurs. The movements of rock sends out waves that travel to Earth's surface. An earthquake wave is called a seismic wave. Okay? Seismic or seismic waves are mechanical waves because they move through matter. Without matter, they cannot actually transfer. Remember again that mechanical waves needs a matter or a medium to travel. When you say medium, it is something that is being used in order to travel. Medium. That's singular. Media is plural. Okay. Okay. So as you can see, there are three types of seismic waves. We have P wave or the primary wave, S wave or the secondary wave, and of course the surface waves. Okay. Properties of waves. When scientists describe waves, they describe the properties of wavelength and frequency. Wavelength is the distance between a point of one wave, such as the crests. Okay, the crest to crests and the throw to throw. That is actually the wavelength. At the same point, the next of the wave is called wavelength. Okay, different types of waves can have wavelengths that range from thousands of kilometers to less than the size of an atom. How about frequency? Frequency is the number of wavelengths that pass a point each second of a wave's frequency. Okay. Like for example, in 1 second, how many wavelengths does it pass? That is actually the frequency. Frequency is measured in hertz. Okay. In honor of Henry Hertz, which discovered the frequency. The longer the wavelength, the lower the frequency. As the distance between the crests gets shorter, the number of waves passing a point of each second increases. Of course. Okay? Again, as distance between crests gets shorter, the number of waves passing a point of each second increases. Okay? Waves speed. Okay, a wave speed depends on the medium or type of material through which it travels. Electromagnetic waves always travel through empty space at the speed of 3 by 108 meters per second. That is 300 million meters per each second. Okay? They travel slower than the through a medium or a mat because they must interact with particles. Mechanical waves also travel slower through matter because the waves transfer energy from one particle to another. For example, sound waves travel about 1 millionth the speed of light. The speed of water waves depends on the strength of the wind that produces them. Correct. Amplitude and energy. By the way, do you have any questions so far? Questions so far?
None.
Okay. Wave's amplitude is the maximum distance of a wave varies from its rest position. For mechanical waves, amplitude is the maximum distance the particles of a medium move from the rest positions a wave passes. The more energy a mechanical wave has, the larger its amplitude. Remember the amplitude? The one that I actually illustrated to you a while ago? Remember the amplitude? Huh? This one? The amplitude again is the distance from the central axis going to the crest or going to the throw. That is the amplitude. Okay? Wavelength is the distance from crest to crest and throw to throw. Okay? Again, wave's amplitude is the maximum distance of a wave, varies from its rest position. For mechanical waves, amplitude is the maximum distance the particles of the medium move from the rest positions a wave passes. The more energy of a mechanical wave has, the larger its amplitude. Again, the amplitude is the distance from the central axis going to the crest or going to the throw. Okay, this one. Okay, you can see the amplitude here. That's the amplitude from the central axis going to the throw or going to the crest. Okay, wave interaction with matter. When you knock a door, longitudinal sound waves transfer the energy to the knock through the door. However, when a person in next room hears the knock, it is not as loud as the sound on your side of the door. Why? Because the sound is weaker after it passes through the door. Because the waves interact with the matter that makes up the door. So, it makes it more, what? More weaker. So the sound there is weaker compared to the sound that you are into or you are actually outside the door. Okay? Transmission. Okay, some of the sound from the knock passes to the door, the wave transmits or carry the energy all the way to the door. The energy then passes into the air particles and the person on the other side hears the knock, but it is weaker. Absorption. Some of the sound is absorbed by the particles that make up the door instead of passing through the door. The energy increases the motion of the particles of the wood. The sound energy changes into thermal energy within the door. Therefore, less sound energy passes through the air in the next room. That is why it is weaker. Reflection. Some of the energy used to knock the door reflects or bounces back into the room you are in. So the sound waves in the air transfer the sound to your ears. That's why you can hear. Okay? Do you have any questions so far with this? Grade 7?
No.
Okay. Let's continue the law of reflection by next meeting. I want you to study in advance the next lesson or the next topic, which is the law of reflection. So what is the law of reflection? How this being done? What are the properties of this law of reflection? And so on. Right? Question so far? Grade 7?
No.
Okay, reminder. We will have computer 7 this afternoon. Again, we will have computer 7 this afternoon. And upon checking, um, only few actually submitted their performance task. But, well, it's up to you. Okay? Already given you chances. Let me check on your computer 7. Creating presentations. No one actually submitted the creating presentations. What do you want me to do? Grade 7. Grade 7. In your computer 7, you didn't submit a PowerPoint presentation. Okay? Let me share my screen. I will let you see. Okay, can you see my shared screen now? Can you see my shared screen? Grade 7? Okay. Creating presentations, no one or nobody actually submitted. What's the problem? Okay, the instruction here, it says, create a PowerPoint presentation entitled My New Year's Resolution. Use your own creativity in a graphics templates of your choice. This will serve as your performance task for the third quarter. So without this, you might fail. This is worth 50 points. Okay, let's talk about this by this afternoon. I'll be opening this activity by this afternoon for the last time. Right? Alright, grade 7? Okay. I think that will be all for today, class. Thank you for your participation. Although you didn't actually talk, but you are actually there listening. I want you again to participate by next meeting. Thank you and goodbye, grade 7. Have a nice day.
Fine, thank you.